everyone, I'm Jerry Wills. I have with me today a man who has invented a prototype of an actual warp drive engine. It's a bit more sophisticated than that, but in general layman terms, that's what we have here. We have a device that creates a warp bubble, and this is very truly used as a means of propulsion. There have been tests conducted and proof of thesis has been established. So, instead of me telling you about it, I'm going to have this person come on and tell you about it himself. He is Professor David Paris, and I think you'll find this just absolutely remarkable. Hello, David. How are you?
I'm good, Jerry. How you doing?
I'm doing really good. Nice afternoon here in the deserts of the Great Southwest. Looks like it's about 75 degrees outside. How is it where you are?
In Nebraska, Omaha, we're 23 degrees right now.
Well, we're
getting chilly. The winter has arrived.
We're about 52 degrees difference. Well, you know, I've told folks that you were going to be on and what you've done. And I think it would be good for them first to know who you are. And then after that, we'll go into the details of what you've done. Go ahead.
Okay. I'm Dave Paris. I'm a adjunct professor at several universities. I teach 10 different subjects in science from meteorology, astronomy, physics, geology, geography. And in aviation, I have commercial license, and I've done rocketry, electronics, software. So I've actually been involved in a lot of technical areas in my whole career. In addition to teaching for 22 years, I have been in defense contracting. I've had my own companies, which Quantum Electrodynamics is the current company that we are developing our prototype of the warp drive. Within the next year, we are looking to take this to space and put it onto a small microsat and to prove the proof of concept of the device. It all started back in 2010 when I started to investigate some reports that pilots were getting thrown out of clouds or experiencing linear displacement. And these reports go back to World War II to present day. And in addition to that, even though that they could be considered anecdotal, being a pilot myself, I was rather fascinated with the individual pilot accounts, and I have interviewed several of these pilots. So, being that many people consider their cases anecdotal, I actually took them into the lab. I figured, well, if nature is doing this, essentially the relationship between two thunderstorms, the crossing of electric fields within thunderstorms, this is indeed a very brute force method, but it does occur in nature. And like I said, we've had about 10 different cases that have experienced this over the years, and it proved to be worthwhile to take it into the lab to try to recreate this. I have done several TV programs with one of these pilots, Bruce Gernon, and in doing so, I was able to bring a lot of equipment with me on board the aircraft, and as we flew through thunderstorms, I captured a lot of data. And so what I did was I brought that back into the lab and set up a series of antenna structures that would emulate the RF signature of these electric fields. And well, one experiment led to another. And we were able to, at least in the initial experiments, take a laser beam, put it through an interferometer, activate the field, and compress the laser beam onto the screen, which was developed at fringe pattern. And from that, after turning the system off, it would blossom back out. Turn it on, it would blossom in. And this was just 25 watts of power that we were able to do this. So initially we thought there might be something here. We need to do some further investigations, which then led to developing a fractal array, and that meaning that we were able to take antenna structures that were 12 foot in length and shrink them down into a usable package of just a few centimeters. And so what we did was develop these fractal arrays, which basically went against each other in the shape of a V form. And with that said, we were able to, in the near field, bounce these signals back and forth and cross over into the middle. So kind of like from one side to the other, and then cross them, and there would be a focal point, which then pushed the, as we talk about, the compression of the fabric of space in a downward direction into the motor. And this developed a actual pulling engine versus a thrusting engine. So that made it very unique. So the qualifications that we discovered, we assembled all the various parameters of what the actual results of developing this motor were. And we went to Harold Puthoff, a space-time metric spaceport scientist who's been doing this for years and years. And we presented to him, and it was a phone conversation, but we presented to him the various characteristics of what we had discovered with the engine results, which was a redshift and frequency of the motor, being able to influence objects through solid objects. We had a very unique experiment. We called it the modified Cavendish experiment, where there was a box, glass, and wood. He had a torsion bar inside, and we adapted metal spheres to a torsion bar. And we also took non-ferrous material, or in this case, wood balls, and put them onto the torsion bar and set the motor up to 140 centimeters away from the box and actually influence the material being suspended on the torsion bar. And we got rates of swing, which it wasn't due to electrostatics, it wasn't due to any kind of a charge, but rather the engine pulling power, the fetch point of the motor, literally tugged onto the spheres and moved them. And so we recorded all of these things, and the characteristics of which we found, of what we found, were verified by Harold Puthoff. And so we went from there to build bigger and larger engines. And right now, the concept is fully scalable. We have a 1 foot model, we have 2 foot models, and we have 3 foot models. And we put them in various configurations, clustering in quad formation, kind of acting like gimbals. And we're experimenting now with being able to increase the pulling power of the engines by altering the angles of the engines to cross their fetch points, which is the longest distance of influence from the base of the engine. And a lot of the other characteristics that we have been able to demonstrate all somewhat fall in line with Miguel Alcubierre's theory of warp drives, compressing in the front. However, the decompression in the back is not equivalent to the compression in the front. What we discovered was that the decompression in the back tapers off gradually. It's not a one-for-one compression, decompression. We have had up to 3 pounds of pull on our Model 19, which is a 2-foot model. And on our website, qed-ne.com, you can view all the experiments, read our papers. We presented to the AIAA, and we have written numerous papers about providing and generating artificial gravity onboard spacecraft using these engines. Some of our smallest variants, of which you could use 10 to 20 watts of power to literally either grow plants at 20 watts of power with our smaller engines, is to literally have an astronaut's feet attached to the floorboards of the spacecraft. So we have done biologic testing with the engines. There's really any appreciable radiation. We have measured 1.5 microrads of radiation coming from the motors, which background usually 12 to 23, at least in this area here in Nebraska. During the day varies. We've run specific fly tests, laboratory flies and control groups, and ones that were exposed to the engines for over a series of time, and have gone out to the second generation of the fly groups, the control groups, and the ones that were experimented with. And there aren't any mutations or any differentials in their behavior and mutations of any type. So I'm pretty well confident that from a bio perspective, it's benign to humans. So this is, I believe, a very good potential for creating artificial gravity in space. For spacecraft use, human occupation for long distance travels within space. One of the other unique properties of our warp drive of scalable concept is that we experience a constant acceleration with the unit. So, for example, our 3-pound unit that we have could go to Mars in less than 18 days. So our calculations are pretty solid on that, with just a small increase in power, which is really exponential in the engine. As we discovered, the pulling power increases dramatically as you just increase power slightly. So this is another great advantage in the engine development, and that we're trying to minimize the amount of energy that you require to pull the engines to where you want to go. And in other words, so for 3 pounds, we have achieved that with 1,500 watts of power. And during that experiment, actually, we broke the scale. We had a 20 Newton scale that we were using at the time, and we maxed out the scale and it broke. And in order to break those scales, you need at least another 8 pounds of pull on the scale. But we're only recording the 3 pounds that were measured, even though that we do know that it pulled a lot more than 1,500 watts. So that's what keeps us going on this is to keep refining it so that we develop engines that don't require as much power, but yet you get a lot of work output. And it is exponential by nature. So getting back to Alcubierre and some of the theories that he had of the compression of the fabric of space, yes, that works. The decompression in the back, we discovered was that it tapers off gradually. It's not a direct one-to-one correspondence, and that the tidal action on the exterior of the bubbles that are created are not as violent as what he was predicting. Although maybe if we're up into the copious amounts of power ratios, that could that happen? It's a possibility, but everything that we've seen so far is that it doesn't really exist. And the bending of light around the warp drives, we have not detected that. We do videotaping of all of our experiments and go back and track everything that's there and analyze and see if there's differentials and whatnot. So from that aspect, we've been very happy with the evolution and development of the engines. Of course, everything takes money. And a lot of all my teaching goes back into getting this forward so that we can develop a actual commercial grade engine that could be applied to satellites for station keeping, eliminating the need for ion drives. Our engines do not require any propulsion, any propellant. They work on electric capacity, 48 volts DC through some linear amplifiers. We send out a signal from our exciter. It is throttleable, and then you can go from 0 to max power of whatever your system allows. For us, it's 2,500 watts right now. We do have the capability of going up to 6,000 watts of power. We do our experiments in Faraday cages just to make sure that after 14 years of development and being around this stuff, we just wanted to minimize any potentials. Although we have proven that the engines themselves really don't deliver any kind of biohazard. But from a RF perspective, we want to minimize our exposure to the outside world. In other words, sending out signals. We do have licenses for these and whatnot, so we're well within our regulatory parameters to exercise these engines. And from the perspective of where do we go into the future, it's bigger and better. It is scalable, and we've shown everything from small engine development to larger engine development. The other thing that we've also shown is that to create warp bubbles, you do not need to generate a huge encompassing warp bubble from one source. We've actually have demonstrated that you can create multiple warp bubbles from one engine to the next and generate a larger bubble as a result of the engine setups that we have. So that leads us to full axial control, being able to go left, right, up, down, backwards, forwards, any direction that you want to do based on the engines that are applied to the spacecraft. Now, these could be field manipulated, in other words, by varying the fields around the craft. You can also induce axial control to the craft as well. And so this leads to other potentials. The fact that there is no propellant, you could use either solar, battery power, You could use plutonium reactors, which are essentially electric heating devices that can generate electricity in the spacecraft. So there's multitudes of different kinds of ways to energize the engines for space travel, which also makes the spacecraft much lighter, since you do not have to carry an inordinate amount of fuel to get from point A to B. And the fact that you can have this continual acceleration build up. For example, if you wanted to go to Pluto in about 126 days versus with the ion drives of the Project Horizon took 10 years to get there, we could do that in about 126 days because of the accumulative accelerated process. And this is just based on the 3-pound unit that we have. So there's a tremendous amount of potential. Could we go faster than light? I mean, that's my ultimate goal, is to do that. But right at this point, you got to crawl before you walk and before you run. So this is where we're at in comparison to any other device that's out there in space, ion drives, Hall thrusters, and whatnot. But we do literally run rings around them because our amount of force can be generated in less than 20 seconds, whereas it takes days, months, and years for many of the devices to get up to a point where they get to 25, 50,000 miles an hour. So 10 years, 3.3 billion miles to get to Pluto, 126 days versus 10 years. What engine do you want? So this would open up a whole space-based economy to space mining, perhaps 16 Psyche, getting to the asteroid in an appropriate amount of time, logistically, just within a few weeks to getting there, and coming back with the load of ore, gold, silver, platinum, whatever. And no matter how much of the expense to get there, I think the estimate was a Googleplex of trillions of dollars of potential money to be made from mining. And it's mining on the moon, helium-3, all these things that people have talked about. It's nothing new that I'm discussing here. I mean, it's been out there for years of discussion. But I think that the technology that we're beginning to introduce will give us the capability to make space travel faster, less hazardous, and also being able to, with more powerful engines, launching from the Earth to space, taking materials, people, and then from space to wherever the destination would be. One of the other interesting aspects of our engines, I forgot to mention, is that there's a cooling effect around the engine cell itself. We've been able to indicate or measure results of 4.5 degrees Fahrenheit temperature reduction when the engine is activated. Now, there have been a lot of people out there that have seen this, and they claim that it's electric wind, it's this, it's ionized air, blah, blah, blah. Well, it has worked in a vacuum, and the temperature differential pretty much matches up to what the Navy saw in the Tic Tac episode back in 2017 when they had their thermal infrared cameras on the device. There was a cooling aspect around the vehicle itself, which to me indicated that they had a warp-based technology and highly advanced, more than what we have right today, but along the same track. of this cooling aspect of a warp bubble around the craft. So we've discovered quite a few things. You can pulse these engines. You can maintain the power to the engines for continued pull. We've noted when you turn them off, you can get spikes of energy that come off as the collapse of the warp bubble goes back to normal space relative. And one of our other aspects here from theory of relativity is that mass and energy in these particular situations are equivalent. So the type of compression of the fabric of space that you would get around a black hole, the sun, a planet, Jupiter, are all equivalent. But in our particular case, we can artificially induce this with the throttle and collapse the fabric of space. And by the way, this does alter the field of gravity around the engine itself. For the 2 gravity doses that would adhere an astronaut to the floor, that's 1.47 meters per second squared of force that would keep an astronaut to the floor of the spacecraft, which has many, many advantages, obviously. You don't have to work out as much. Atrophy of the body, the extremities of the body wouldn't atrophy. You would still have to exercise to keep in shape in space, but not as radical as what they have to do today. And the duration of space could be actually longer versus when they come down and they get out of the capsules. Many times they have to be carried out because they've been in space for such a long duration. With this type of artificial gravity, in addition to the engine technology, one would just walk out of your spacecraft like nothing happened. So that kind of in a nutshell is what we've accomplished here in the last 14 years. It's been very frustrating in many cases. It's been very rewarding, but we're on the cutting edge of a new technology, and I guess in some respects, we may be the only ones doing this. There could be others out there. I'm unaware of anybody else that's doing this. So I kind of feel like we're kind of writing a new chapter in the science of warp technology and how it works, how you can employ it, and how it can be used for humanity. I think space would be the great place to start with this. And then as the units be able to grow, is that it would affect all the transportation on the face of the earth. In other words, going across the oceans from one continent to the other, being able to move massive amounts of people in similar like aircraft, but within seconds to get from point A to B. And that's ultimately what I would hope to at least inspire and get accomplished, is rapid transportation, not only around the world, but obviously to look at the solar system and go places beyond the solar system to some of our closest places in space, Proxima Centauri, Alpha Centauri, and then maybe even out to Gamma Epsilon. But again, this is kind of very futuristic in many respects. However, I cannot give you an estimate as to the rapid development of this type of technology at this point. It's been slow and very painstaking to get everything just right, everything to work. But it looks pretty encouraging to move into the future of more advanced engine technology to accommodate for faster turnarounds to get from point A to B, and maybe approaching light speeds and beyond. I don't know. Remains to be seen. So, you have any questions, Jerry? Anything I maybe left out or you want to know more about?
No, I think that covered it very completely. The one thing that I remember when you showed this to us, and this was, the low powered unit, and I've told people about this over and over, is when you shot a laser across the warp field and it bent the laser. The light was just, I've never seen anything like that. I don't understand how something like that could be anything but a warp field. That's what I think a warp field would do. The other thing that I think, is worth mentioning again is a test you conducted several months back. You had a 5-pound scale. You mentioned newtons. I'm sure some folks understand this, but I don't. But you had a 5-pound scale. It's one of these that hangs with a hook on the bottom, right?
Right. Mm-hmm.
You had the warp generator right there hooked up to it. You powered this thing up, and it broke the scale. It just broke it.
Yes, that is correct.
So you have no idea how much power that you created in that moment. That's an odious amount of power. I don't know how to transliterate that into anything except, you've got something that broke a 5-pound scale. Well, that's significant.
Yeah, it takes about 8 to 10 pounds to break the springs in the 20 Newton scale. That's what we use, the specific scale. And it translated to where the weight of Model 19. Oh, by the way, we've developed over 23 models of this engine in various sizes and also configurations of fractals and whatnot. There's been an awful lot of work. There's a ton of money that's gone into this. But yes, you're right. But we only claim the 3 pounds that we were able to measure on the scale, even though that we knew that we broke it and went to the end of the operational limit of the scale and literally broke it, physically broke it. So
went to its limitations and then beyond.
Yes, yeah, but we only publish what we saw on the scale, despite the fact that it broke. But 3 pounds is what it registered, the equivalent. It's 15, basically. Yeah.
Yeah, about 15 pounds altogether.
Or no, 15 newtons of force. However, translated into with breakage of the scale would probably yield in about 10 to 13 pounds. But
and how many,
like I say,
how many newtons
we're not broadcasting that piece of it. We only broadcast that we did 15 newtons or 3 pounds equivalent.
How many newtons is, 15 pounds?
How many newtons is 15? Oh,
yeah.
It's like 45 pounds, I believe, something like that.
45 newtons?
Yeah.
All right. Not that it makes a lot of sense to me because I'm not at that point in understanding newtons, but all right. Well, there's a lot of things that I can think of that have probably not even crossed your mind because they don't. You're busy developing this, but like many people who are watching this, they're going to be thinking, what else could you do with this? What's possible? And I think that all it requires is just, an imagination to get to a point where you can just start imagining what could you do. Even with something that's displacing, let's say, 10 pounds of force.
Mm-hmm.
if you had that, what could you do? Last question I have before I let you go. Um, let's say you had one that's doing, I don't know, like you said, 45 newtons. You had this on a satellite. The satellite has terrific, those little nuclear generators for power. You turned it on and pointed it. Is it such that as long as that thing's on, it continues to accelerate until something stops it?
That's correct. Yeah.
So really, there's no known upper limit to the amount of speed that this is capable of generating. It could just run away with itself until it just, who knows? I mean, surpasses the speed of light, perhaps.
Well, I have done a lot of research on the what we consider like entangled particle, entangled space. What are the upper limits of that? Well, essentially, it would be the amount of energy that would create a black hole. And that's something like 26 million billion watts of power. In typical thunderstorms, they generate 10 to the 15th watts of power, which in a brute force environment, aircraft have been displaced 100 and 300 miles on the documents that I've done research on. So,
and that means they disappear from here and reappear over there.
That's correct. And they go about 360,000 miles an hour. That's how fast it's a blink of an eye when you get that kind of energy together. And this is unbridled force. I mean, it's not a focused force. It's just what happens between the fields and the thunderstorms.
Right.
And, within thunderstorms itself, they generate antimatter. There's positrons being generated in there. And that's 500,000 electron volts for every action. And they're not just one or two of these actions going on in the thunderstorms. There's enough that produce these gamma rays that in one instance, I was 20 miles away from, in 2012, I heard Tropical Storm Betty down near Naples, Florida. We were doing a program for National Geographic, and I was measuring back to the storm 70,000 gamma rays a minute, which meant that there was a tremendous amount of, and these storms were up to 78,000 feet, tremendous amount of antimatter being generated within these storms to generate that kind of gamma ray activity.
Wow.
Even at 20 miles, we were getting bombarded. And according to FAA, you're not allowed to fly closer than 20 miles unless you've got to land at an airport. But flight-wise, you need to divert, go around these thunderstorms. 20 miles is your limit. We're being advised to turn back as we flew towards this thing. We turned back at 22 miles due to a thunderbolt lightning that came right across the power of the aircraft. And that was signal enough for me to tell the pilot, we need to go back. And put the film in the can.
Yeah, I suppose so.
It was real dangerous at that point.
Yeah, I've flown through thunderstorms, not quite like that, but I was pretty damn close, and it was very uncomfortable.
There's a clear air, CA, clear air lightning bolt came out from those storms at 22 miles from the main cells of those storms over Naples. And it was time to exit stage right and go back to West Palm Beach, Florida. Those were quite the days. I had a lot of relatives call me and say, you got a family, you got little kids at that time. why are you doing stuff like this? Well, it's calculated risk, I guess. I didn't anticipate getting a lightning bolt 22 miles away from the storm,
No, I
but it
suppose
did.
not.
But, look, nothing ventured, nothing gained, as the colloquial expression goes.
That's true.
There's risk in everything that you do. And for advancing technology of this nature, I want to go to space. I always have wanted to. But I always thought that there had to be a better way than chemical rocket engines, ion drive. And I guess this raw brute force method that nature has created, and aircraft have been, gone into its inner parts of the storm and being ejected out, was more than just fascinating to me. So, from a physics point of view, is nature at its best. It's really demonstrated to us, and emulating nature. That's, really what I've done is being a meteorologist and having done all the various jobs in meteorology, from weather radar, upper air, weather observations, forecasting, writing numerical weather models, all of that experience, and plus all of my other background that I have, it was kind of like a big detective story, trying to figure out how these airplanes managed to get displaced out of these clouds. And I believe I found the answer to that because I was able to recreate it in the lab. And, we're just constantly moving forward from whatever we develop from one engine, carry it forward to the next and the next, make them bigger, better, less energy, get more out of them. So there's a real goal for refinement. And of course, there'll be a point here that we can't refine anymore to get the most amount of so many watts or so many pounds of force, pulling force of the engine. So it is quite unique, and I would encourage people to go to the website to take a look at the images and the videos. We would be, wasting a lot of time showing pictures and things, but you've got the audible explanation, the verbal explanation, and now you just need to fill it with the images from the website. It's got everything there. So,
All right.
I would encourage everybody to look at it.
Well, I'll make sure I put the web address with this video. Something of this nature, where there is actually some proof of thesis. It seems to me that of all the people in the world I can think of, Elon Musk would be a person who would find this immensely interesting. So, if you're watching, Elon Musk, I would suggest looking into this. All it requires is a little bit of your time. And what if there's something to this? If there is, well, this might just be the next chapter in our pursuit of moving outward towards the stars. Getting to Mars in, would you say, 9 days? That's remarkable. The only thing left to do at that point is communication. And if you folks are curious about that, there is someone who's working on quantum communication using entangled particles. His name is Dr. Eamon Ansbra in Ireland. He's a friend of mine, just like you are a friend, David. And he's getting closer and closer to being able to communicate real time over any distance. So I think that these two facets, when put together, equal the ability to not just move out there in interplanetary space, but to actually conquer interplanetary space and have real-time communication while you're doing it. These are real things, folks. Science fiction has now taken a back seat to science fact. Can't think of anything else. Any closing statements, David?
No, just take a look. I mean, most people don't believe that any of this is possible. It's a paradigm shift, and in that process of being a paradigm shift of understanding and belief, it really comes down to more of an educational process of showing how it works and at least the basic constructs of it and what we've discovered. I think it warrants additional investigation and evolution and development, because I believe, honestly, is that space-based economy is the future for the planet Earth. Mining, colonization. Eventually, we're going to move out into space, but chemically going out into space is just not logistically possible. The amount of time involved here, the logistics, it's just, I believe, insurmountable. But when you have a propulsion device that can get you from point A to B very quickly, then that is the solution to the problem that makes space access viable for humanity.
Well, thank you for being on with us, David. Stick around after I close out. I'll say goodbye to you properly. But thank you very much for taking some time to explain this to everyone.
Well, thank you for having me on your show. You take care, Joe.
You too. So there you have it, folks. Professor David Paris, the inventor of an actual, real-life, working warp engine. The possibilities at this point are just, it's really hard to get your mind around what could be done with something that has potential that this warp engine prototype is suggesting. I think that it is incumbent upon all of us to realize that the way we've done things in the past, where we've used the rockets that we're used to, with large thrusters and multiple bodies that have to be discarded, using chemical propellants, those are rapidly becoming a thing of the past with the development of a warp engine. I believe the future is bright, and our ability to go out there among the stars is now closer than ever as a result of the work of Professor David Paris. Information about how you can contact him, his website, and so forth will be with this video. I want to thank all of you for watching. I'm Jerry Wills. If you're interested in other program content like this, you can go to jerrywillsshow.com. It's a membership site, and you're certainly welcome to come and check it out. Thanks, everyone. I appreciate you watching. I will see you again very soon. But for now, well, it's time for me to fade away. So long, everyone.